states of matter gas laws we covered, that is ideal gas equation, even ideal gas equation of state, density based relations also we did, that is Boyle's law, Charles law, Avogadro's law, and second Charles law or Gay-Lussac's law. Then based on Boyle's law, Charles law, Avogadro's law, ideal gas and ideal gas equation. PV equal to nRT is an ideal gas equation. Correct? Here Boyle's law V is directly proportional to 1 by V. Charles law V is directly proportional to T. Avogadro's law V is directly proportional to N. From these three, V is also directly proportional to 1 by V into T into N, or V equal to some RT N by P, or rewriting it PV equal to N or T is an ideal gas equation. Right? The gas which obeys all the gas laws and all the conditions of temperature and pressure is called an ideal gas. The gas which obeys all the gas and all the conditions of temperature and pressure called as ideal gas. Now here if a gas obeying these three gas laws, then LHS of these three expressions equal to volume. Therefore volume is also directly proportional to 1 by P into T into N, or V equal to RT N by P, or PV equal to nRT is an ideal gas equation. PV equal to nRT is an ideal gas equation. Or either density term में हम लाना बोले तो PV is equal to N you can write as actual mass by molecular mass into RT. Molecular mass left side law, volume right side law. P into molecular mass equal to actual mass by volume into RT. Correct? Actual mass by volume is D, so DRT. DRT is P into MW. Correct? P into MW or molecular mass, product of the pressure and molecular mass of a gas is equal to DRT, where R is a gas constant or universal gas constant or ideal gas constant we can say, and this R value yesterday I given total list, right? 0.0821 liter atmosphere per degree into mole CGS. उनका liter to milliliter changing, atmosphere to centimeter changing and millimeter changing, because one atmosphere equal to 76 centimeters, 760 millimeters. Based on that different R values. Bar में थोड़ा बढ़ के रहता, that is 0.083 bar liter bar per degree into mole. Right? 8.314 into 10 power 7 hertz per degree into mole. 8.314 joule per degree into mole, or 1.987 calories per degree into mole. So those are various R values yesterday already I given. Now density based P into MW or M is equal to DRT. For two gases from here, if you check PV by NT equal to R. Correct? PV by NT equal to R. That implies here P1V1 by N1T1 is equal to P2V2 by N2T2, because if it is so, for first gas P1V1 by N1T1 equal to R. Similarly for second gas P2V2 by N2T2 equal to R. RHS of these two equations are constant. Therefore, equating their LHS we will get. This equation is said to be ideal gas equation of state. इनको क्या बोलते हैं? Ideal gas equation of state. Very important. V to the power of n times important. इनके ऊपर क्वेश्चन आने का. Even whatever the individual gas law is there, all the gas laws comes under here. Therefore, universally up to the gas laws, whatever the kind of problem they given, all kinds of problems you can calculate by using this one. P1V1 by N1T1 equal to P2V2 by N2T2, known as ideal gas equation of state. This N you can rewrite if you want. P1V1 M1 divided by W1 into T1 equal to P2 V2 M2 divided by W2 T2, since N equal to actual mass by molecular mass, the number of moles. How can we define the mole? The ratio of actual mass to its molecular mass of the substance is called a mole number. Therefore, N1 is W1 by M1. That M1 goes to the numerator. Correct? Or from this V1 by W1 here, W by V is D. W by V is D. V by W 1 by D होगा. So therefore P1 V1 V1 इधर चले जाएगा. करेक्ट ना? P1 M1 लिखना. P1 M1 divided by V1 by W1 1 by D. So that is D1 T1 equal to P2 M2 divided by D2 T2 in terms of densities. करेक्ट? इधर देखो ये कैसा लिख सकते हैं? Pm by dt is equal to for two gases P1 M1 by D1 T1, P1 M1 by D1 T1 equal to P2 M2 by D2 T2, P2 M2 by D2 T2. Clear ना? So whatever I wrote, see compulsory from this एक question आने का chance है. Therefore be careful. Properly observe करो and perfectly पढ़ो. पढ़ने के बाद इनके ऊपर प्रॉब्लम्स करने को कैसा करेंगे, टेक्स्ट बुक प्रॉब्लम करते देखो, वो टाइम पे हम एक्सप्लेन कर देंगे. Clear ना? So this is ideal gas. So gas laws. Next law is Dalton's law of partial pressures. Dalton's law of partial pressures. Dalton's law of partial pressures. Okay. What do you mean by partial pressure? Partial pressure बोले तो suppose two or more different gases are collectively exert some pressure. That pressure we can call as total pressure. और total pressure में one gas exerting pressure is called its partial pressure. Suppose इधर एक कंटेनर में इनको मैनोमीटर अरेंज करें. This is a container 1. This is the manometer. In manometer, gas A, exerting pressure is PA, existing at room temperature and occupying 1 liter volume. Let us assume in 1 liter container, gas A existing at room temperature exert PA pressure. This is the partial pressure. Clear na? It is the partial pressure. That how much is there? This manometer is going to measure. So similarly, another container with the same volume, gas B, exerting pressure PB, existing at room temperature in 1 liter vessel. Clear na? In 1 liter vessel. It is also connected with the manometer. It is the 1 liter vessel. This is also 1 liter vessel. So in 1 liter vessel, here individually A gas is there, here individually B gas is there. When these two are going to send in another 1 liter vessel, it is A plus B. A plus B collectively exerting pressure is total pressure. This is also existing at room temperature in 1 liter volume. So here also manometer will be arranged and here that pressure is going to decide. Right? Here क्या है इधर at same room temperature, nothing but temperature keeping as constant. Volume also keeping as constant. So at constant temperature and volume, correct? At constant temperature and volume, the total pressure exerted, this is PT. A and B दोनों गैस है ना, दोनों गैस का टोटल प्रेशर एक्सर्टेड इज इक्वल टू सम ऑफ द पार्शियल प्रेशर्स ऑफ इंडिविजुअल गैसेस। इधर देखो Pa प्लस Pb, ये इंडिविजुअली रहे तो प्रेशर ऑफ ए, इंडिविजुअली रहे तो प्रेशर ऑफ बी। इसमें Pa इज कॉल्ड पार्शियल प्रेशर ऑफ ए बिकॉज़ मिक्सिंग में है ना। Here Pa is called partial pressure of A, here Pb is called partial pressure of B. So our this Dalton's law क्या बोलते हैं? According to this Pt is there, see Pt is equal to Pa plus Pb, the total pressure exerted by mixture, correct? The total pressure exerted by mixture. ये mixture में और एक condition रखना, the gases should not react together. A और B दोनों गैसेस को एक कंटेनर में रखे तो वो दोनों बीच में रिएक्शन इन्वॉल्व नहीं रहना, नो रिएक्शन, सो नथिंग बट नॉन रिएक्टिंग गैसियस मिक्सचर रहना। सपोज इफ दे स्टार्ट द रिएक्शन इंस्टेड ऑफ एक्सर्टिंग द प्रेशर दे आर गोइंग टू यील्ड द प्रोडक्ट्स, करेक्ट? वो प्रोडक्ट्स देने में बिजी रहता हो, प्रोडक्ट देने में बिजी रहे तो total pressure exerted definitely not equal with the sum of the partial pressures of their individual gases. Therefore एक ऐसा बोल सकते हैं कंडीशन क्या है? at constant temperature and volume, correct? at constant temperature and volume the total pressure at constant temperature and volume the total pressure exerted by the mixture of non-reacting gases, the total pressure exerted by the mixture of non-reacting gases is equal to the sum of the partial pressures of their individual gases. थोड़ा इधर चेक करना प्रॉपर्ली, कंफ्यूज नो। एट कांस्टेंट टेम्परेचर एंड वॉल्यूम, टेम्परेचर वॉल्यूम कांस्टेंट रखिए, एक रूम टेम्परेचर 25 डिग्री सेल्सियस 25 डिग्री सेल्सियस 25 डिग्री सेल्सियस एट कांस्टेंट टेम्परेचर एंड वॉल्यूम 1 लीटर वॉल्यूम 1 लीटर वॉल्यूम 1 लीटर वॉल्यूम, करेक्ट? एट कांस्टेंट टेम्परेचर एंड वॉल्यूम total pressure exerted by the mixture of non-reacting gases, इधर A और B mixture, C रहे तो C, A B C D so on, कितना भी रहने दो, the total pressure exerted by the mixture of non-reacting gases is equal to the, that is PD, is equal to the sum of the partial pressures of their individual gases, correct? इसमें A exerting pressure is PA, that is the partial pressure. B exerting pressure PB, that is also a partial pressure. So sum of the partial pressures of these two non-reacting mixture definitely equal to the total pressure exerted by the mixture of non-reacting gases. समझ में आया definition? So this is experimental proof and definition. Okay ना? The according to Dalton's law क्या बोलते हैं? Dalton's law of partial pressure, the total pressure exerted by the mixture of non-reacting gases. What is that? PT. At a constant temperature and volume, the total pressure exerted by the mixture of non-reacting gases is equal to the sum of the partial pressures of their individual gases. Correct? Sum of the partial pressures of their individual gases. So that is Dalton's law. समझ में आया ना? So इधर क्या रहता? PT equal to PA plus PB. Okay ना? Suppose इधर first condition में गैस का पार्शियल प्रेशर P1 है समझो एंड इनका वॉल्यूम V1 फर्स्ट, सेकंड में इधर P2 एंड हियर V2, V1 एंड V2 may or may not equal, V and V2 सेम रह सकते नहीं तो डिफरेंट रह सकते, मगर these two gases send into another फाइनल वॉल्यूम एज VT में सेंड करें. At that time, here the total pressure exerted definitely PT na PT. What is PT here? PT1 plus PT2. Correct? PT1 is what? PT1 partial pressure of the first gas in its mixture. A total mixture में partial pressure of the first gas is PT1. Total mixture में partial pressure of the second gas PT2. So now sum of the partial pressures of first and second gases is equal to total pressure. ये दोनों का partial pressure is equal to total pressure. Sum of the partial pressures of first and second gas is equal to total pressure. Therefore, here P1 is what? Pressure of first gas. It is not the partial pressure C. ये individually इनका container में रहे तो partial नहीं हो सकता. Therefore, P1 is the partial pressure of first gas. V1 is the volume of the first gas. Similarly, P2 partial pressure of second gas. V2 volume of the second gas. When these two gases are sent into VT may or may not equal to 1. May or may not equal to 1. रहे तो total volume VT. In total volume VT में here first gas exerting pressure is PT1. Second gas exerting pressure is PT2. So now the sum of the partial pressures of these two gases is equal to PT, total pressure. Therefore problem पूछने में ये इसके ऊपर बहुत important देखो ये very important concept इनके ऊपर क्वेश्चन पूछने का प्रॉब्लम पूछने का चांस है. वो लोग क्या देते? फर्स्ट कंडीशन का P1 V1 देते, सेकंड कंडीशन का P1 V1 देते. देने के बाद फाइनल वॉल्यूम में देर पार्शियल प्रेशर पूछ सकते, नहीं तो देर टोटल प्रेशर पूछ सकते. Therefore पार्शियल प्रेशर बोले तो इसे इधर कैसे करना? According to Boyle's law. According to Boyle's law क्या बोल सकते हैं हम? According to Boyle's law P1 V1 equal to PT1 VT. देखो ये दोनों को कंपेयर कर रहे हैं 1 and 3. P1 V1 equal to PT VT होना, मगर PT VT according to first gas PT1 रहेगा. Therefore P1 V1 equal to PT1 VT implies PT1 is equal to P1 V1 by VT. Correct? PT1 is equal to P1 V1 by VT. Similarly here P2 V2 equal to PT2 VT. प्रॉब्लम करने में important expression याद रखो. It is according to Boyle's law. P1 V1 equal to PT1 VT. Therefore PT1 equal to P1 V1 by VT. Similarly for second gas P2 V2 equal to PT2 VT implies PT2 is equal to P2 V2 divided by VT. Clear ना? PT2 equal to P2 V2 divided by VT. Now हमारा क्या मिल गया? PT1 मिल गया, PT2 मिल गया. What are PT1 and PT2? The PT1 and PT2 are the partial pressures of the first and second gases in VT volume. Correct? The partial pressures of first and second gases in VT volume. What are P1 V1? Here what are P1 P2? Here the pressure of first gas. It is not the partial pressure. It is the pressure of second gas, not the partial pressure. Because individually है ना, एक ही कंटेनर में है, therefore उनका total pressure. एक ही कंटेनर में है इनका total pressure. When these two are mixed, at that time we need VT volume. PT1 is the partial pressure of the first gas. PT2 is the partial pressure of the second gas. Therefore total pressure PT is equal to PT1 plus PT2. Clear na? So this is the Dalton's law. PT equal to PT1 plus PT2 is the Dalton's law. Nothing but the total pressure exerted by the mixture of non-reacting gases is equal to the sum of the partial pressures of the individual gases at constant temperature and volume. वही प्रूव हो गया ना? राइट? लाइक दिस प्रॉब्लम, इसके ऊपर प्रॉब्लम पूछने का चांस है. नहीं तो ओनली ये दोनों देते फाइनल टोटल प्रेशर पूछने का चांस है. ये एक्सप्रेशन में प्रॉब्लम और अकॉर्डिंग टू दिस द प्रॉब्लम दे आर गोइंग टू फ्रेम. क्लियर ना? सो नेक्स्ट इनका ये एप्लीकेशन में हम बोलते हैं स्क्रीनशॉट लेना. और एक बार सुनो, स्क्रीनशॉट लेके नोट्स में सेट कर दे। ओके ना? नेक्स्ट, you know PV equal to nRT. PV equal to nRT as an ideal gas equation, correct है? और इनको रिराइट करें तो P equal to nRT by V. Just V I am bringing to the right side, that's it, correct है? If it is so, this implies P1 equal to N1 RT by V at constant temperature and volume. डाटा स्लैश इधर दिखाई होगा, टेम्परेचर और वॉल्यूम कांस्टेंट रहता है, राइट? thus P1 equal to N1 only varies. P1 equal to N1 into RT by V and P2 is equal to N2 RT by V. So on PT is equal to NT RT by V. Correct? PT equal to NT RT by V. All these are at the constant temperature and volume. At constant temperature and volume, P1 equal to N1 RT by V, P2 equal to N2 RT by V, then PT equal to NT RT by V. Correct है? Then partial pressure बोले तो हमारे को मालूम है क्या बोल के? The pressure exerted by one gas in its mixture of the gases. Therefore, here partial pressures of the gases, partial pressures of the gases as follows. Partial pressure of the gases as follows. That is P1 by PT. P1 by PT is partial pressure of first gas. Pressure exerted by one gas in its total pressure exerted by the mixture of gases. P1 by PT equal to P1 क्या है? N1 into RT by V divided by N2 into RT by V ना, NT into RT by V ना, या P1 N1 into RT by V, PT NT into RT by V. Now RT by V getting cancelled implies P1 by PT is equal to N1 by NT. That N1 by NT is X1, where X is mole fraction of the gas, correct? Mole fraction of the first gas. How can we define? The ratio of the number of moles of first gas to the total number of moles of all the gases in a solution. Already some basic concepts of chemistry में methods of expressing the concentrations of solutions में हम decide करें, correct? The ratio of number of moles of one gas to the total number of moles of all the gases in a solution is called solution. बोले तो uniform mixture. यही गैस में uniform mixture ही रहेगा ना. Therefore, the ratio of number of moles of first gas to the total number of moles of all the gases in a mixture is called its mole fraction. Therefore हम क्या लिख सकते हैं? P1 is equal to X1 into PT. लिख सकते हैं ना? Similarly, for second gas क्या हो सकता? P2 equal to X2 into PT. So on Pi, ith gas, infinity gas, Pi equal to Xi into PT. It is one more expression to calculate the partial pressure of the ith gas. Correct है? Partial pressure of ith gas calculation में Pi equal to Xi into PT. Very important expression is also. Very important expression. Pi equal to Xi into PT. Thus, the partial pressure of ith gas is equal to product of the mole fraction of ith gas and total pressure exerted by the mixture of non-reacting gases. Correct? Partial pressure of ith gas is equal to product of the mole fraction of ith gas and total pressure exerted by the mixture of non-reacting gases. Pi equal to Xi into PT. Very important. Even हमारा को chemical equilibrium बोल के next lesson रहता है important lesson, उधर भी इनका application use होता. Therefore, you must be careful with this one. This is one more expression. Clear ना? Okay. So next, suppose if the gas, it is one container. It is one container, open vessel, in which volatile liquid is there, say water. ये वाटर है समझो, ये वाटर के ऊपर हम क्या कर रहे हैं, एक जार इन्वर्ट कर रहे हैं. I am inverting a jar like this. एक जार ऐसा, a jar is inverted over a liquid. ये जार का वॉल्यूम कांस्टेंट है ना? It is taking place at some fixed temperature. So at 25 degrees Celsius, 1 liter vessel. Temperature and volume kept as constant. So at constant temperature and volume, the total pressure exerted by the mixture of non-reacting gases is equal to definitely sum of the partial pressures of their individual gases only na definition. So when a jar is inverted over a water, तब क्या होगा? ये वाटर ऐसा evaporation हल्लू से होगा ना? evaporation होगा. ये वाटर वेपर से पहले इधर गैस ड्राई गैस था ना? ऐसा इन्वर्ट कर रहे देखो, like this as we are inverting, here air वैसे रहेगा ना, certain gas will be there ना, that gas collectively exerts some pressure. वो गैस का प्रेशर एक रहता. now इनके साथ ये वाटर के ऊपर ऐसा इन्वर्ट करे तो ये वाटर वेपर्स evaporate होगा ना, these vapor molecules additionally होगा ना. so here dry gas एक पहले था, इधर dry gas एक पहले था, dry gas along with that water vapor centered up, water vapor centered. Therefore, the water vapor pressure here called as aqueous tension. The pressure exerted by only water vapor is equal to aqueous tension, that can be total pressure from its container minus the pressure of dry gas. Aqueous tension होना बोले तो aqueous tension क्या है? Pressure exerted by the vapor of a liquid. Aqueous बोले तो water है ना? Aqueous meaning water. अब हम क्या कर रहे हैं, एक वेसल के ऊपर, वेसल में पानी रखे, और पानी के ऊपर like this a jar is inverting. We are inverting a jar. ऐसा इन्वर्ट करे टाइम पे इसमें रहे तो गैस वैसे ही रहता ना. Here whatever the gas is there, that gas वैसे ही रहता. You are also many times you are going to try. Even while doing bath, whatever your mug is there, say, वो मग को क्या करते, ऐसा पानी में इन्वर्ट करे तो वो मग नीचे नहीं जाता. कहीं को नहीं जाता बोल के तुम फोर्स करे तो जाता, मगर तुम फोर्स विथड्रॉ करे तो हाथ निकाल दिए तो ऊपर आ जाता. नहीं तो ऐसा थोड़ा उनका पोजीशन चेंज कर लेते, चेंज करके इधर रहे तो गैस एस्केप होगा. गैस एस्केप होने के बाद वो सिंक हो जाता. गैस वैसे रहे तो सिंक नहीं होगा. So therefore, like that a jar when we invert, तब क्या होगा? A water का vapor evaporate होगा. Evaporated vapors will be inside the jar, inside the jar. उसमें पहले क्या था? Dry gas. Now that dry gas is wetted by the vapors of this water. So now only the pressure with respect to vapors of the water is called aqueous tension. At constant temperature and volume, the pressure exerted by the vapor of water when a jar is inverted over a liquid, when a gas is collected over a liquid, when a gas is collected over a liquid, along with that gas, whoever the liquid vapors are there, see, the liquid vapors exerting pressure here called as aqueous tension, denoted with F. Aqueous tension को denoted with F. F is what? इसमें रहे तो dry gas pressure and water vapor pressure. Water vapor pressure and dry gas pressure दोनों का sum is PT. PT से total pressure से dry gas pressure, PG बोले तो dry gas pressure, total pressure से dry gas pressure को हम subtract करें तो बचे तो pressure is aqueous tension only ना, or the pressure with respect to water vapor only ना. Therefore, your aqueous tension is equal to total pressure minus dry gas pressure. ये इधर हमारे को P1 V1 by N1 T1 equal to P2 V2 by N2 T2. ऐसा comparison में first gas और second gas comparison में P1 V1 N1 and T1 ऐसा रहे तो here P2 V2 T2 and N2 ऐसा है समझो. P1 V1 T1 N1 P2 V2 T2 N2 ऐसा रहे तो इधर क्या बोलते, कैलकुलेट द प्रेशर ऑफ द गैस, ये दे दे एट एसटीपी ऑफ 1 मोल, बोले तो V2 22.4 लीटर होगा, T2 273 केल्विन होगा, for 1 mole is N equal to 1. When a gas is collected over liquid, its pressure is, बोल के इधर क्या तो देते, that is 1.23 एटमॉस्फेयर बोल के दिए समझो, इधर पूछे, here STP 22.4 liters, here T2 273 Kelvin, N2 equal to 1, here also N2 equal to 1, this will be at 25 degrees Celsius, बोले समझो, 25 degrees Celsius plus 273 is 298 Kelvin होगा, 298 Kelvin, some 2 liters of the gas. ऐसा ये फर्स्ट एक्सपेरिमेंटल वैल्यूज क्या था, वो एक्सपेरिमेंटल वैल्यूज इन्होंने देते, मगर इधर एक गैस इज कलेक्टेड ओवर ए वाटर बोल के दिए, व्हेन ए गैस इज कलेक्टेड ओवर ए वाटर इन 2 liter vessel at 25 degrees Celsius, its pressure is 1.23 atmosphere. Nothing but a 1.23, whoever is there, 1.23 atmosphere is PT only ना, PT. लास्ट में ब्रैकेट में एक्वियस टेंशन ऑफ द वाटर बोल के देते होंगे, एक्वियस टेंशन ऑफ वाटर इज 0.23 बोल के देते, तो 0.23 हियर व्हाट F. देयरफॉर तुम इनको प्रॉब्लम में सब्स्टिट्यूट करने में P1 V1 by L1 T1 equal to P2 V2 by L2 T2 करते हैं ना, उसमें ये P1 ड्राई गैस प्रेशर कंसीडर करना, so therefore here PG is equal to PT minus F. इधर PG इधर लाओ, PG इधर लाए तो F उधर गए तो माइनस F होगा ना, therefore 1.23 minus 0.23 equal to 1 atmosphere कंसीडर करना. ऐसा whenever a gas is collected over a liquid or whenever a gas is collected over a water, the pressure exerted by the vapor of a water, the pressure exerted by the vapor of a water at constant temperature and volume is called aqueous tension. प्रॉब्लम में aqueous tension बोल के दिए तो तुम टेंशन नहीं लेना, क्या करना, एक्सपेरिमेंटल प्रेशर से उनको सब्ट्रैक्ट कर देना, करे तो ड्राई गैस प्रेशर हो जाता, और ड्राई गैस प्रेशर सेकंड कंडीशन में कंपेयर करके व्हाटएवर द काइंड ऑफ प्रॉब्लम दे आस्क्ड, वो प्रॉब्लम हम कैलकुलेट कर सकते हैं. क्लियर ना? सो दिस इंफॉर्मेशन फ्रॉम डाल्टन्स लॉ ऑफ पार्शियल प्रेशर, इंपॉर्टेंट क्वेश्चन आने का चांस है. डेफिनेशन में क्या है, टेंपरेचर एंड वॉल्यूम केप्ट एज कांस्टेंट, एंड और एक कंडीशन क्या है, हियर द गैसेस हु आर मिक्सिंग टुगेदर दे मस्ट बी नॉन रिएक्टिंग टुगेदर. एक गैस और एक गैस के रिएक्शन में इन्वॉल्व नहीं रहना. सपोज हाइड्रोक्लोरिक एसिड गैस एंड अमोनिया गैस सेंड इनटू ए वेसल बोल के बोले, तब क्या होगा, हाइड्रोक्लोरिक एसिड readily reacts with ammonia because HCl is an acid, ammonia is the base. वैसा तुम from periodic properties concept और chemical bonding में bond parameters concept, chemical bonding concept, periodic table concept दोनों एक जगह को लाके whether they are going to react or not, your brain has to decide. वो experience से brain decide करना. हम दिए तो एक 10 पेयर दे सकते, 100 पेयर दे सकते, मगर 1000 पेयर में हम 100 क्या पढ़े उसमें से छोड़ के और एक पेयर देते होंगे, तब हम रेडी रहना ना. Therefore, the concepts of periodic table as well as the chemical bonding, bond nature decide करना, decide करके electropositive, electronegative, smaller size, larger size, lower charge density, higher charge density, whether it is acid or metallic oxide, non-metallic oxide, like that all together consolidate करके वो दोनों गैसेस हम एक कंटेनर में रखे तो वो रिएक्शन में इन्वॉल्व नहीं होना. Therefore, which among the following pair of gases fails to follow the Dalton's law? बोल के पूछे तो रेडी ना, कौन रिएक्शन में इन्वॉल्व होता, वो डाल्टन्स लॉ को अप्लाई नहीं होता. रिएक्शन में दोनों को एक जगह पे रखे तो भी those two could not react together. वैसा रहे तो डाल्टन्स लॉ अप्लाई होगा. सो देयरफॉर उधर एक कांसेप्चुअल क्वेश्चन निकालने का चांस है. फॉलोइंग पेयर ऑफ गैसेस नॉन रिएक्टिंग आइडेंटिफाई करना बाय योर ब्रेन ओनली बेस्ड ऑन कांसेप्ट्स ऑफ पीरियोडिक टेबल एज वेल एज केमिकल बॉन्डिंग. ओके ना, दैट इज वन. नेक्स्ट PT equal to P1 plus P2 plus P3 plus so on. one more. Next PT1, P1V1 by VT, PT2, P2V2 by P2V2 by VT. So that P1, PT1 plus PT2 is total pressure, PT. वैसा. And next ideal gas equation P equal to N naught आपको मालूम है, उसमें टेम्परेचर एंड वॉल्यूम कांस्टेंट रखे तो तब P1 फर्स्ट गैस को P1 इक्वल टू N1 into RT by V होता, P2 इक्वल टू N2 by R, N2 into RT by V, like that PT is NT by R, NT into RT by V. पार्शियल प्रेशर का डेफिनेशन क्या है? The pressure exerted by one gas in its mixture of the gases, that is P1 by P2 is partial pressure of first gas, P2 by PT partial pressure of second gas, so on. PI by PT, PI by PT is partial pressure of ith gas. इनका एक्सप्रेशन क्या है? N1 into RT by V. इनका एक्सप्रेशन क्या है? NT into RT by V. Now RT by V getting cancelled. P1 by PT is N1 by NT. P1 by PT is N1 by NT. That N1 by NT is what? X1. The ratio of the number of moles of first gas to the total number of moles of all the gases in a mixture is called its mole fraction. So that is denoted with the X1. So that P1 equal to PT इधर लाए तो X1 into PT. Similarly P2 equal to X2 into PT. So on PI equal to XI into PT. For ith gas, partial pressure is equal to product of mole fraction of ith gas and total pressure exerted by the mixture of non-reacting gases. Clear ना? PI equal to XI into PT. Similarly इधर aqueous tension बोल के one more word है, nothing but when a jar or a dry gas containing jar is inverted over a liquid, ऐसा वाटर के ऊपर इन्वर्ट करें तो थोड़ा देर होने के बाद वाटर वेपर्स इधर अंदर आने का चांस है, इसलिए पहले रहे सो गैस का प्रेशर क्या था, अब उनके साथ इधर वाटर वेपर्स भी एंटर हो रहे हैं, therefore the pressure exerted naturally will become more. That total pressure PT if I define PT से ड्राई गैस प्रेशर हम सब्ट्रैक्ट करें तो ओनली वाटर वेपर का प्रेशर बचता. दैट वाटर वेपर का प्रेशर हियर कॉल्ड एज एक्वियस टेंशन. वी कैन डिफाइन अकॉर्डिंग टू टर्म्स एंड कंडीशंस. ऐसा एट कांस्टेंट टेंपरेचर एंड वॉल्यूम द प्रेशर एक्सर्टेड बाय द वेपर ऑफ ए लिक्विड व्हेन ए जार इज इन्वर्टेड ओवर ए लिक्विड is called its aqueous tension, denoted with F mathematically. F equal to PT minus PG. Clear? So this is in detail Dalton's law of partial pressures. Okay na? Next Graham's law of diffusion. One more है. Graham's law of diffusion. Graham's law of diffusion क्या बोलते हैं? ये एक्चुअली हमारा एनसीईआरटी बुक में नहीं है, मगर इनके ऊपर क्वेश्चंस में पूछ रहे हैं. ग्राहम्स लॉ ऑफ डिफ्यूजन. ग्राहम्स लॉ ऑफ डिफ्यूजन, गैसेस ओनली विल डिफ्यूज, व्यापना बोलते हैं, डिफ्यूज. वाटर कैन फ्लो, ह्यूमन कैन वॉक और कैन रन. Correct? Here gases only will diffuse. Gases will not walk. Human will not diffuse. Diffuse बोले तो against the gravitational force, opposite to gravitational force, they will travel as it is. उनके ऊपर gravitational force negligible. वो gravitational force से gas molecules ground में नहीं बैठते. No gas can take a rest. At least a moment also गैस रेस्ट लेने का चांस नहीं है. एट पर्टिकुलर टेम्परेचर उनका काइनेटिक एनर्जी क्या तो थोड़ा रहता. अकॉर्डिंग टू काइनेटिक एनर्जी दे कैन मूव हियर एंड देयर अगेंस्ट द ग्रेविटेशनल फोर्स. गैस क्या भी रहने दो, ऑक्सीजन रहने दो, हाइड्रोजन रहने दो, नाइट्रोजन रहने दो, हेवियर रहने दो, लाइटर रहने दो, क्या रहे तो भी एट पर्टिकुलर टेम्परेचर एवरी गैस possess certain kinetic energy. Due to that kinetic energy the gas molecules can move here and there against or opposite to gravitational force. Correct? If they take the rest, we will take the permanent rest, because no gas will be ready, no gas will be ready to breathe. Therefore gases for the sake of us comfortably they are going to move here and there. Correct? So the movement of the gas molecules from one place to other place opposite to gravitational force is called diffusion, right? Or spontaneous intermixing of the gas molecules. Different gas molecules spontaneously they are going to intermix. Spontaneous intermixing of the gas molecules opposite to gravitational force is called diffusion. Okay, to diffuse the gas molecule, some time takes place from wall, one wall to other wall gas diffuse होना. इधर से इधर आना बोले तो क्या तो थोड़ा time लेते हैं ना. So with respect to time, whatever the movement of the gas molecule took place from one plane to other plane, with respect to time is called rate of diffusion. Graham's law of diffusion में rate of diffusion. Rate of diffusion, the change of the gas molecule position from one place to other place with respect to time here called as rate of diffusion. Such rate of diffusion according to Graham at constant temperature and pressure, the rate of diffusion of any gas, the rate of diffusion of any gas is inversely proportional to square root of its density. Square root of its density. So this is Graham's law of diffusion. क्या बोलते हैं Graham's law of diffusion? At constant temperature and pressure, the rate of diffusion of any gas is inversely proportional to its square root of density. Mathematically, क्या लिख सकते हैं? Is 1 by its square root of density. Like this we can take at constant temperature and pressure. That R equal to some K by root D implies R into root D equal to K. Therefore, R1 into root D1 for first gas is K1 and R2 into root D2 for second gas is K2. Here K1 and K2 RHS are constant. Therefore, that implies R1 into root D1 is equal to R2 into root D2, or R1 by R2 equal to square root of D2 by D1. This is for two gases Graham's law of diffusion. For two gases Graham's law of diffusion क्या है? The ratio of rates of diffusion of any two gases. The ratio of rates of diffusion of any two gases is equal to the square root of the ratio of their invert gases. The ratio of rates of diffusion of any two gases is equal to the square root of the ratio of their inverse densities. Equal to square root of the ratio of their inverse densities at constant temperature and pressure. At constant temperature and pressure, the ratio of the rates of diffusion of any two gases is equal to the square root of the ratio of their inverse densities. That is Graham's law of diffusion in terms of density. And in terms of molecular mass different, in terms of vapor density is different, in terms of just volume and time also different. Right? So whatever the different expressions are there, those different expressions we can solve tomorrow also. That will be R1 by R2 equal to square root of D2 by D1 equal to square root of M2 by M1 equal to square root of VD2 divided by VD1 equal to V1 D2 divided by V2 D1 बोल के different expressions are there. All these different expressions let us do tomorrow. Actually NCERT में नहीं है मगर इनके ऊपर क्वेश्चंस आ रहे हैं, so उसलिए हम चांस काहे को लेना बोल के एक्सप्लेन कर रहे हैं. So therefore here this expression से rates of diffusion तक क्या हम कवर करें अब तक गैस स्टेट में. कमिंग संडे एग्जाम यहाँ तक आता. कमिंग संडे एग्जाम अप टू Graham's law of diffusion your syllabus. Therefore आज से ही परफेक्टली प्रिपेयर हो जाओ. राइट टुमारो ये एक्सप्रेशन हम इधर लाया ना, इधर से एक ऐसा आता और एक एक बार रिपीट करके इनके ऊपर किधर तो क्या तो छोटा मोटा प्रॉब्लम्स है तो हम क्रिएट करके तुम्हारे को एक्सप्लेन कर देते विद दैट कॉन्सेप्चुअल पार्ट और प्रिलिमिनरी स्टेट एलिमेंटरी स्टेट में बोले तो छोटा छोटा प्रॉब्लम्स हो ऐसा क्या रहे तो एक्सप्रेशन के ऊपर यूनिट्स उनके ऊपर क्वेश्चन पेपर आने का चांस रहेगा। थोड़ा केयरफुली पढ़ो, पढ़ के कमिंग सेंटर लिखना। राइट, ओके, गुड लक।